So can you see my screen?
Yes, it's visible.
Okay.
Yeah, yeah, it's in present mode. That's right.
Okay. So very good morning, everyone out there. So first of all, I have to appreciate my Croatia Journal for giving me this opportunity. And as usual, Dr. Chennai, he's a fantastic person who is bringing all the innovators and inventors and the academia and scientists together on one platform. So we have to thank and congratulate him first. So with this, I'll start my presentation. So today I won't be too much technical. I will be talking about my journey from a forest explorer and a wanderer, how I started my enterprise, what I was thinking. So what are the strategies that I was following to bring mycelium into the forefront of the industry. So, why this topic is important? The first important thing is mushroom adaptation is very less in India when compared to the Southeast Asian countries where they are exploring the or exploiting the full potential of mushrooms in every aspect that is possible. So, how I am bringing it forward. So, from my start to my current position, so I will talk about everything. So this whole thing will be in chapters. So let us start. So that young teenage guy is me. So my journey towards mushrooms is something which is noteworthy. I started this in my late teens, somewhere around 18, 19. So we three people in the photo there, we used to hike inside out of Eastern Ghats. So every day, so where is Aditya? Nobody knows where is he. The college, even the college, my professor were a little worried. But I used to go to deeper parts of Eastern Ghats to search, so to just wander. Um, in that wandering, you can just see this video was taken in a deep forest. So you can see the even the grass was almost 7, 8 foot tall. You don't know if the leopard is sitting next to you. You don't know. So that kind of explorations we used to do a lot. So why we used to do, we don't know when we started, but it became I think the adrenaline rush for us. So it looks beautiful from outside. You get beautiful sunrises and sunsets. You think you are on the top of the world, but in the reality, you will camp somewhere in the darkest of dark nights. So you don't know what insect is next to you. The next human civilization will be somewhere around 70, 80 to 100 kilometers away. So if you are dead, you are dead. No one is coming, nobody is coming to get you. So that kind of things we used to do. And the mornings would be like this. So this is one of the jungles in the Eastern Ghats region. Um, so now what happened was while we are doing this journey, I felt a deep passion and connect with the mother nature. So I very specifically call it mother because the nature, in the nature, we found a couple of things. One, nobody is a loser in the nature. Everyone gets profited. And everyone are made sure those are well fed, right? So these kind of small intuitive knowledges I gathered over my journey. So then we used to have this very old Jeep with us where we used to roam and these kind of things over 1 or 2 years once we gained experience. So we started, a friend of ours started a permaculture farm. So permaculture is called permanent agriculture. So this is one of the most important things. So right now we are using a lot of monocropping and these kind of things for getting our food. But permaculture, so the main idea is so let the trees grow in such a fashion, it will create its own forest like a structure. So if you work for 5 years on this, so the next 500 years, the farm you create, it has to give you the food without you keeping. your hand or even your thought into it. So in that, I used to stay on this what can I say, hut little above the ground. We started a farm where the food is abundant. We call it the food forest. So where the morning, early mornings, you wake up in the morning, you can straight go into that forest. There will be some fruit or other that is ready and ripen. You can pluck it and you can eat it and you can start your day. So that kind of a thing we did. So here, when we are making this food forest, when we are trying to understand how plants communicate with each other, we found one important bridging network. So that network was fungi. So the if the land was very well inoculated with the local fungus, if the local fungus is growing, so along with the bacteria and others, so the plants are getting nourished all by themselves. So human intervention can be completely zero. So with this simple idea, we found if I have to accelerate the growth of the plants, so I should not take care about the plant, but I have to take care about the fungus in the soil. So this incubation brought me close to the fungi, and this is where I had my deeper connect, or the aha moment we call. So I have to do something with the fungi. Um, at that point of time, I don't know. I was not very venture loving, on enterprise loving guy. So I was more, I can say, on the lines of the I can say red philosophy. I want to help everyone and these kind of things. So then when I came little forward, I understood like, when a business is created in such a way that the ethos of that business reflects how nature does business. So nature never gives anything for free. Nature always makes sure everyone are satisfied and profitable. Um, and it makes sure everyone are fed and happy. So these kind of things are there in the nature inbuilt. That's why you are seeing a thriving ecosystem around you. So we thought like, okay, why can't I build a business that brings about these kind of a values? This was the idea that started in my 20s. So this is where I thought like, okay, fine. Now it is my time to do something. Um, so in this meanwhile, so that moment came to me just because of biomimicry. So in the depths of the forest, I used to read on a hammock about this biomimicry and these kind of things. So what is this biomimicry? So the name says it all. So mimic is like mimicking, and bio is the biology. You need to mimic the biological organisms out there. You can do it on a organism level to ecosystem level, so whatever level that is possible. So if there is some lesson you can learn, so you need to implement it. For example, you see the bullet trains out there. So the shape, the front part of the bullet train was inspired by a Japanese engineer from Kingfisher. Right. So in the same way, there are our Velcro, so which is widely used. Velcro was inspired from a plant. So the plant seed sticks onto the fur of animals, so it will be transported and pollinated long distances. So in the same way, I thought I took nature as my model, measure, and mentor. So we started exploring various strategies. In the forest, we started exploring how nature purifies water. So there is no RO water purifier inside a forest. So you need to understand how nature purifies its own water. You can drink from a stream and you can still survive. The first thing we learned is there are some lessons. Like the first thing I learned is water should always flow. You can drink from a flowing water, but not a stagnant water. Um, so the river bed is a most essential water purification system. So if all the animals, I can say if most of the birds are drinking, you can think you can drink in that lake or a pond. So then these kind of golden rules were there in the forest survival mechanism. So based on that, we went and explored. We found how water gets purified by plants along the beds. And when we are little bit exploring, we found fungus even in that moist kind of a environment. So I was little surprised. Fungus is not only helping forests or plants to grow. It is even there where there is water. So then I went back, when I went back to the city and I saw some research papers and I found fungus can be used for water filtration. So these guys are really fantastic in absorbing a lot of toxins and heavy metals. So this even encouraged me to think fungus can be used literally everywhere and anywhere. Um, so my passion became little bit more interested, a little bit more elevated towards working with the mushrooms. So using these kind of principles, I wanted to start a company using it should be an intersection of ethos from the nature, so a strong biomimicry based thinking, strategizing kind of a structure, and fungi as my model organism. So with this three intervention, I got empowered to start Roha Biotech. So Roha means growth. So in Sanskrit, it's what growth exactly is when a bamboo or a plant shoots out of the soil, that kind of a shooting growth is called Roha in Sanskrit. So I want to keep I just kept this name. So from the biomimicry, after seeing how fungus is everywhere, my love story towards fungi, the fungi story has started. So um, for us, fungi means something for everyone. So for some people, fungus means mushroom. For some people, fungus means toxin. For some people, fungus means, it's hallucinating. For someone, it is material. Uh, so everyone has their own view, uh, own perspective, how they look at fungus. So let me share my perspective, how I look at the fungus. So for me, fungus is a versatile enzyme production factory. So this enzyme production factories, they are very intelligent, very smart, very adaptable. And when you throw a very complex challenge that tests their survival, right? So what they do, they break that problem down into the basic elements. So for example, if you give them a cytotoxin, say a very you name one of the most cytotoxic element, or for example, say plastic or polystyrene. So when you train the mushrooms enough, they break this plastic down into very basic unit, and they consume it. From that, they produce something useful for the human beings or the plants or the whole ecosystem. So they are taking something completely not suited, and they are thinking, and they are breaking the problem down into bits and pieces, and they are rebuilding it into something useful. So after I observed this, I thought like, oh my God. So there is nothing like mushrooms or fungi in the whole world. So they are this ideal entrepreneurs. So they are making the whole ecosystem go live and thrive. And mushrooms, when we started digging little bit deeper, we started to understand mushrooms not only communicate with other species of mushrooms, but they communicate with plants in a way. They can even communicate with you. So take a little dose of magical mushroom, even they can speak to you. I'm 100% sure. So uh, how when we started exploring the plant and fungal interactions, we found mushrooms are really good at trading. Let me say how. Plants can make a lot of carbohydrates or simple sugars, right? So, but mushrooms who are saprophytic, they are not photosynthetic, so they need to rely on a lot of dead and decaying organism. So the symbiotic fungi, they even don't grow on dead and decaying organism. They grow on living plant matter, mostly mycorrhiza and these kind of things. So what they do is they talk to they trade with plants. So for example, if plants need one molecule of sodium for its survival, so it will charge one molecule of glucose, so something like that. If you need little more precious mineral, for example boron or zinc or calcium, so you need to trade more glucose to the mycorrhiza, these kind of organisms. So they actually are communicating with the plants, and they also can transfer a lot of data. For example, when you step into a forest, so if there is a mycorrhiza or fungal hyphal network under your feet, so they know that you are there. And if you are a threat, they can pass that information across the forest floor so that everyone will get informed that there is a threat coming, right? And these kind of things they can do. So this is one kind of fungus. The other kind of fungus. So Professor Sridhar has covered a lot about the funguses that are out there. So some can make you a zombie, some makes the insects zombies and they take over the exoskeleton and they perform. So those kind of things are also there. So they are both heroes and devils at the same time, if you see the whole picture of it. This is where we thought to build little more. We thought to go little more deeper into the fungus. So we also found one more thing, that mushroom shares their resources and bond with other mushrooms to survive. So when we are doing work on building biomaterials, so one of the challenge we faced is how mushroom will not become a mushroom but a material. So how I have to train it. And there are a lot of infections out there. So since we are not doing for food, since we are not doing valuable goods like leather, so packaging is a more, I can say, commodity kind of a thing. So I should not get a lot of pest attacks or contaminations while we are doing. So what was the strategy? What was the innovation I did was, we have a fast-growing mushroom species that we use for packaging. Now I used to go to the forest, bring a wild strain, and we used to cross my original strain with the wild strain. So what wild strain I used to bring? So I used to go to the tropical climates because India is a tropical country. So I chose tropical mushrooms. So the host is attacking the widespread of that mushroom mycelium. So these things we used to check. So it was a lot of tedious work inside a forest. Um, then we found 3 or 4 species and we brought it back and when we crossed. So fortunately, after say a couple of hundreds of atoms, so we got one particular offspring that was really fighting off any contamination, showing a good growth. Then we thought like holy grail of the packaging, and we started producing. So this enabled me and my company to grow mycelium composites with less infrastructure and less need for clean rooms. And this actually helped me scale up in really long. So these kind of techniques we used because from the initial days I understood how mushrooms will mate and bond with each other and how they transfer the genes very effectively from one offspring to other offspring. Um, Not only that, mushroom shares a lot of food and also information with each other. So, for example, if one mushroom got infected with a particular kind of a virus. So it will try to communicate with all other mushrooms of that community very, very fast. So I know this inherently. So, but how did I confirm with data? So even now we are doing a particular kind of experiment where we take two electrodes, we stick it into a fungus, and while the fungus is growing, we constantly take the bioelectric signals of that mushroom. Um, for example, when the mushroom is thirsty, it will give a certain frequency of biosignal. So when the mushroom is a little bit, I can say, stressed with the heat and all, the communication it gives changes. When I add a lot of sugar as a treat to it, so the mushroom will actually give a very major spike, saying the bioelectricity will be all time high, saying that it's happy. In the same way, when there is contamination, right? It can actually sense the contamination. It will give a threat signal to the rest of all the cells to be wary about what's coming. So these kind of things we did, and we were really astonished that these beings uh, are very intelligent and they are super. So literally, I think they are aliens. Um and the mushrooms are shy beings. They are intelligent underdogs of the forest. So I can literally say that. So 90% of the mushroom is never above the ground. It's always inside the ground. And whenever it needs to spring and produce spores, so it will try to come out as a mushroom. So that's why you see them coming in the rainy season. So we little bit worked on why they only come in the rainy season. Why not summer or winter? Um, this questioned a lot of so I didn't sleep for many days. Why this is happening? Even now, I don't know why it is happening, but I found some clues. So what triggers the mushroom to come out? So when there is a lightning strike, um, the mushroom production, say, for example, in a particular patch of a land, a lightning struck. So if the mycelium is there for in that piece of land, so it will double the growth of mushrooms. So the mushrooms will shoot two times more than what it is where lightning was not struck. So this research was done by some couple of Japanese people, and I also observed the same thing in my journey. And other important thing is while the lightning is striking or the atmosphere is pretty much more rainy kind of a thing. So there will be a lot of traces of O3 ozone. So these minimal traces of ozone are actually triggering the mushroom to shoot up. So we used this similar kind of a technique, and we introduce little bit of ozone periodically to trigger the mushrooms to grow, the mycelium to grow fast while we are doing mycocomposites and these kind of things. So we this was one wonderful observation that we did. So before starting this company, I had many ideas to start with. So the first crude idea was enrichment of local water bodies with indigenous fungi. So what happened? So once I came out of the forest, when I started living with my family in my village, um, I found a pretty interesting thing. So when an animal was dead and the rotting process was really slow and it is giving a lot of foul odor. So when I was in the forest, there are many animals dead, but you won't get a lot of bad smell. Instead, it will become into a fertilizer in no time as possible. So I went back to the drawing board and I understood why this is happening. Um, so when I did little more research, so we understood we use extensively pesticides, herbicides, fungicides to clear off all the bad bacteria or fungus inside the crop. But more than it affecting the bad bacteria and fungus, it is affecting the good guys out there. So these good guys will convert a dead animal into fertilizer with very less order as possible. So this was missing. This was missing where? Not in the urban areas. Surprisingly, it was in the rural areas. Rural areas, it is more. So then we thought like, okay, this is not a good idea because pesticides are not going to go away really soon. People will be continuously using. So, but if I can re-inoculate a patch of land and talk to the locals saying that, you don't put fertilizer runoff water or pesticide runoff water into this land. So let it stay as natural as possible. It will be useful for you in coming few years. So what we did was we did a trial experiment where we took gunny bags or jute bags. So in this jute bags, we stuffed a lot of agricultural waste after crop waste, and um, I inoculated lot of forest fungi that is very local there, and poured little bit of jaggery water with little bit of calcium supplement, and we dug 3 or 4 feet down, and we filled this gunny sack and we left it. So we did it just before the rainy season, so that mushrooms, the mycelium has more chance to live. Um, so that turned out really well in our region. I found the mushroom, the indigenous fungus population again started growing really well. So, but will it spring into action in the fields very soon? I don't think so, because whenever this fungus try to colonize the next patch of land, if there is a fungicide that is really strong out there, it cannot grow. But that patch of land was really good. But once people realize and start natural farming, slowly I think these local fungus can take over. So this is the work I did. So I want to take it to a bigger company kind of a level. But when we thought of working on it, we we found it can be much of a social enterprise rather than a profit-making fungi. So if there is no money, there is no honey. So I cannot literally survive if I do that. So we left this idea. We are keeping it for CSR grants mostly. Um, then the next interesting idea is biocides, fertilizers, and seed treatment. So we know trichoderma species are used for seed treatment and also fertilizer. So this is where in our work, we found two very interesting fungus. So one belongs to the family of cordyceps. So when this living fungus is inoculated into the soil, it will take care a lot. It will take care of all the pests that are out there. So we started little bit work on live biocides. Then coming to the fertilizer, we know there are a lot of NPK fertilizers that are available, but I was not too much interested. So we found one interesting fungus that colonizes rocks. So in the Eastern Ghats, if you even in the Western Ghats, I think. So if you start trekking, you find lot of white color patches on rocks. Um, Widely available. So when I started digging deep on this mushroom, so I cannot say the scientific name. I cannot remember, but I know what it is used for really well. These mushrooms, they grow in the fissures of the rocks. Whenever it rains, it will sporulate kind of a thing, or it will little bit grow. But these are really good in breaking down the rocks and extracting minerals out of it. I was like, oh my God, this can be the next big idea. So, for example, imagine you bring a lot of mineral ore. For example, a dolomite ore that is left over in the quarry, or you go bring some rock powder. So, mix it with this fungal inoculum. and grow it in a bioreactor. So this fungus will extract all the minerals out of it, and you can use it as a biofertilizer. If I can modify this mushroom really well into something else, I can even start extracting ore out of this fungus. So this application gave me a lot of enthusiasm, but eventually we left this idea because we found fertilizer industry and the ore industry are very well saturated, and in the Indian markets I cannot crack it. But I kept it little for little later. Um, so in that kind of investigations, we found one wonderful enzyme. As I earlier told, mushrooms are enzyme factories. So we found something called LPMO, so lytic polysaccharide monooxygenases. So this enzyme is, I can say, the miracle enzyme. So what it is made out of? So there will be a ROS complex which will produce a lot of um, oxygen radicals or OH minus. So in middle of that, there will be a copper um, associated in the middle of that protein complex. There is copper. So um, what does this enzyme really do? For example, chemically speaking, take 10% of hydrogen peroxide and add little bit of copper oxide. So the reaction is spontaneous. If you even keep the hardest of cellulosic material onto it, it will get break it down into CO2 within no time. You can break down a lot of complex lignin and not lignin, cellulose and hemicellulose chains into smaller chains. We thought like, okay, fine. If we have to produce a lot of nanocellulose in form of fiber or a crystal, we need the best is there is something called tempo oxidation or mechanical milling. So if I can do it enzymatically, it can be a really big thing. Nanocellulose come to the forefront. So we started working on LPMOs a lot. Then eventually we thought like, isolation of LPMO is really tough. And so this is a very fast acting enzyme. So if I even genetically modify mushroom to produce exclusively this, say after 5% of concentration it achieved while we are growing in the bioreactor, this enzyme will uh, kill the cell itself. So there are a lot of complicated stuff over there and it needs a lot of research. So we thought like, okay, fine, let us leave it for now. And we want to create a carbon trading system that was inspired from fungal network. As I discussed earlier, fungal networks can trade a lot of minerals at a particular rate to the plant species. So we thought of conducting a lot of experiments and derive a theory. So where we can trade carbon credits. So for example, if you are using diesel in your boiler, so we will sell you X amount of carbon credits versus if you are doing biocharcoal or something like this, you will trade, you have to buy less amount of carbon credits. So this was a future interesting idea, but we too didn't take it up because there is a lot of work that is needed. So then we went into the biomaterials arena and we started. So when we did research, so we found biomaterials is something we can try and work it out. So that is where my introduction to industry has started. We got incubated with IITM Bioincubator, and we did a lot of customer research there. Um, Even now we are doing so. In the whole gist of that customer research is this. So plastics are wonderful materials. You cannot deny that. So they made our life easier, convenient, faster and let the humans evolve at a unprecedented speeds. But we don't need them everywhere and forever. So, for example, they can make our trains lighter, but we don't need our fruits to be packaged in a plastic car. So we need not need them literally in every small thing that is out there because we have plastic, so we should not use them everywhere. So this is like this is more like misusing the medicine. So since we have antibiotics, we are just popping these pills in India, left, right, and center. That is bringing a lot of antimicrobial resistance. The same kind of a thought process is being done for plastic. Since we have plastics in abundance, we are using it left, right, and center. So then we thought like, okay, fine. Where in a targeted position, I have to what I can say, I have to target and remove the plastic. So this is where we started working, building packaging materials. So we thought styrofoam has to be replaced in the packaging. Um, since this guy sits in the landfill for 700, 800 years without degrading. So it's not about degrading, leave, let alone leave about it. When styrofoam undergoes thermal degradation, it is pumping out a lot of neurotoxins into the land, which are not really good. So we thought like, okay, fine, this guy is ripen for a disruption, and we started disrupting this. And we made a couple of industrial products. So we right now we are working with a very big automotive giant in India, also one of the big names in the consumer electronics industry and glass industry. So we are basically working with industrial clients because if I can prove myself catering to a big industrial client, so I can prove it everywhere. So this was my kind of a thought while we are selecting our customers. And we're also working with a couple of artists. So the picture you are seeing here is me along with an Italian designer. We are developing India's one of the first sound absorbing wall panels for mushrooms using mushrooms. And we also work on a lot of art. So this is some of the I can say very important designs that we made. Even if you bring these designs using plastic, it is very tough to recreate these kind of a designs. But we have matured in our technology from last 2 years in so that we can even bring very complex shapes using mycelium. So because we were able to do this kind of a complex structure and shapes, we are working with one of the India's very young architectural studio to create India's first mycelium pavilion. So this will be coming somewhere in the December. So this pavilion, yeah. So that's the photo you can look at it. This is being constructed by us right now. So. We have a long road ahead, and we want to be part of this community and present our work and also take your valuable suggestions in the growth. And we believe in decentralization of the knowledge, so that somewhere some thought can add up and it can create something wonderful. So because I was nurtured by many people and many innovators, scientists over a period of time, I was able to achieve this. And I want to decentralize much of our technology that we are doing so everyone could grow. And we are Roha Biotech. Thank you for being very patient with me. Thank you very much.
Thank you, Aditya. That was truly a wonderful presentation. I really enjoyed listening to your story. I think we have three questions so far, Aditya. First, Mohan
Yeah.
Kumar, please. I think I'll let me unmute them. Dr. Mohan Kumar, please ask your question.
Yeah, Aditya, it was a really a good work, and really many youngsters can inspire the way you have started working with mushrooms. So my question is, when you start exploring the forest, so
Yes.
what were your parents' acceptation? What parents used to tell? Because of course, teachers were one way. They were, they were not knowing what Aditya is doing. And what about the parents? Were the parents supported in all your endeavors?
So I'll tell you the truth. They thought I was a gone case. They thought I went nuts. So until very recently, when my So my father visited my pilot plant like couple of months back. Until then, so they were thinking I was a gone case. So you need to accept that and you need to move forward. So there will be a lot of negativity. Or it's not negativity, it's a concern. Uh, it's a parental instinct not to throw you out in the danger. So without danger, you cannot grow. So I took that risk.
Yeah, and already this type of the materials are available. Maybe way back, and if you see, there's a company called Ecovative in US.
Yes, yes, yes.
So it is already there some 15 years back. And
Yes, yes.
how different your product or your concept or knowledge compared to the Ecovative's one?
Okay, this is a very wonderful question. I need to answer it. The first thing, Ecovative's work is more for colder climates. They perform really good in temperate climates. So we are in a tropical climate. So one of the main reason, so because we need to modify the whole industry for India. Just bringing Ecovative strain over here and start producing it, it can give you moderate results individually, but if you need to produce at scale, you need to design for India. So that's what we are doing. And they work in a centralized fashion because their ethos come from capitalism. So India is a free market economy. So if you see the plastic industry over here, which cater to most of the packaging. There will be one big player who makes plastic pellets, and he distributes these plastic pellets across to the MSMEs. For example, Chennai, they will give to a MSME these pellets. For example, Indian Oil gives it. So this MSME will make your tiffin box or water bottle or packaging out of it. So, but not the main guy. So, but Ecovator works like this. So they will have one or two centralized factories, and these people work in that centralized distribution network. So we are building it for a decentralized way. So might be we two are churning out the same product, but from the initial starting sourcing to product distribution, everything on every level is little different with both of us. So yeah,
Yeah, thank
Thank
you.
you.
Thank you. I request the participants to limit to only one questions because we have 10 people in the queue. So if you spend 5 minutes answering two questions, they will be not give the chance. Please try to understand. Thank you very much. Saurabh Chatterjee, please.
Thank you, thank you. First of all, you are doing great job. I the applications of mushrooms in these kind of spheres is really crazy. Thank you for enlightening us. With these inputs. But then my question lies is that is there a way that we can basically utilize the spent substrate in creating some kind of microfabrication which will have like packaging and all of these applications? Because today what I see, right, all of these mushroom producers, right, let it be
yes,
gourmet or mediciners, they have so much substrate, all of them majorly just go into composting.
yes.
Yeah, so is
So
there a way?
true.
Because I was seeing reishi, right? Let's take reishi
Yeah,
mushroom. They have such a tough mycelium that grows all over the substrate. Can
Yes.
we like
yeah.
extract that mycelium, use it for microfabrication in some way?
Okay, so we need to spend substrate is almost all colonized and um, so there are two things. So when the application is for food, you always look for mushroom popping out. So you want that mushroom. So the food that is given is completely different. So when you are coming for when you are coming to materials, the food that is given is completely different. So here we try to incorporate a lot of fibrous content, so that you get the strength, these kind of things. So there the food was easy sugary content. So there is a difference. So even if you make a material out of it, I doubt it can perform for the packaging or construction use, whatever it may be. So this is you have to think from a material perspective here rather than reusing the spent substrate. Because say even if you do it and you launched this product out into the market, if the laptop or a AC that is packaged into it, if it breaks, just because it is not having enough strength, you will still not conquer the market. So this is one of the reasons in our initial testing, we didn't make it through. So, but if someone finds a way, I think it can be a great answer to this. And coming to the spent substrate, so once the cell matures, so even the cell has a lifetime. So I can say 120 to 180 at the day is where you get a lot of mushroom. So this is a older cell. So if you want to grow the packaging really fast, you need younger cells. So which are like 20 days old or 15 to 20 days old. So these kind of cells, they create the texture and that kind of a strength. So which older cells don't really give. So they will form a very hard, sticky layer so that you cannot take it. But the young cells are very much preferable to work with. So this is one of the limiting factor for us to choose the spent substrate from our experience. Um, yeah, so I hope I answered.
Thanks, Aditya.
Uh, Sharad Rai, ask your question, please.
Hi. So first of all, great job. I just wanted to understand when you said you are going for a decentralized model,
Yeah.
how are you going to be able to achieve scale through a decentralized model? And can you elaborate a little bit more on how are you planning to decentralize it?
Right. We are working on a couple of innovations. So we found packaging industry is more interested to take mycelium as a packaging material rather than a traditional mushroom industry. So we are tailoring our innovations right now. One of the main thing is contamination detection. So we have a elaborated platform where I can detect contamination uh, at 4 to 6 hours from it attacked. So rather than if you take it visually, it will take 4 to 5 days. So this will help on one case. So the traditional packaging industry who don't know mushrooms can still detect it with accuracy and faster. The second thing, our mushroom cells. So we are working on hybridization of mushroom cells. So we know our mushroom completely. So I can tailor it to a such a extent that it will listen to uh, the production schedule that we are doing and the cells. So we have a method so where I can transport cells um, at a room temperature. So from one place to another place without I can say without um, any other thing. So I don't need a cold chain basically. So I can transport all my cells without contamination at room temperature. Just I can put it in a postal bag. So our main idea would be producing these kind of cells that we developed over a period of time. So in bulk. So whoever license it, say the traditional packaging industry. So these people will get the cell from us, and our cells can grow literally in a room. You need not to have a AHU unit or something like this or a clean room facility at all. So you can just take my cell, for example, the spawn. So you can break it down into pieces, put it in the agricultural waste, and our cells can grow on any kind of agricultural waste that is out there. We are not sticking to one particular substrate. So that also training we gave from a couple of years. So whatever that is locally available for him, bring it over, put the mycelium that comes in a bag. So here mycelium, you can think it like a Fevicol. So you get agricultural waste, put this natural Fevicol, keep for 14 days, let it grow, you will get your part. So those kind of works we did. We went little genetics and level.
Are you using CRISPR to modify it at a genetic level, or how are you approaching the modification?
Oh, right. So CRISPR is costly. So we have not, though we have enough knowledge to grow till CRISPR, we are not able to do it. We use something called protoplast fusion for now. So this is generally used for tissue culturing of the plants. developing hybrids from the plants, but we developed our own protocol where we can do protoplast fusion for fungi. And if you do normal hybridization, so I can say one in every 20,000 will give you reliable output, 20,000 experiments. So with protoplast fusion, I can cut it down with good methodology to somewhere around 1 in 5,000 sets will give you really. So if you go for CRISPR, 1 in say every 1,000 can give you, but we cannot afford it. But we'll go there eventually.
Thank you. Thank you.
Thank you, Sharaf, for those wonderful questions. Last question from Dr. Manju Sharkey, please.
Hi, Aditya. Wonderful presentation. I would just
Thank
like
you
to
so
know,
much.
I'm working on yeast and plant interactions. So you were talking about interactions and a method that you used to, you used electric, circuits to understand their responses to like sugar and things like that. Could you
Yes.
elaborate on that? How how the unit was, if you have any images that you could share of the unit to understand the signaling.
Okay. So I literally wanted to put that, but currently we applied for a patent on it. But I can elaborate you on the tech. But the signalings are very important to us because we are building a contamination detection system. So what you can do is we worked with filamentous fungi. I never worked with yeast. So you take any filamentous fungi, and there is a particular kind of a electrode which you use for human neurological things. So that human neuro electrodes, you take them, you keep them into the mushroom substrate or mushroom fruiting body or something like this, and you need a reliable data logger for it. So this data logger should capture micro voltage somewhere from microvolts to volts. So that kind of a wide range of a data collector you need. So there are couple in India you can look at. One is Picotech. This is a UK very expensive guy, but in India there are a couple of people you can look at. So this data logger will constantly take a lot of data, and it will give the raw data into your computer. So this is the setup. So how you do? So give stressors. For example, don't give water for 10 days and constantly see the mushroom performance with a test use case. In the same example, you give little bit of what I can say contamination to it and see the signal. So repeat it couple of times so you can understand the interaction, how they are doing.
Okay, wonderful, Aditya, and congratulations. All the very best to your future endeavors.
Thank you so much.
Final comments from Dr. Rohit Sharma, please.
Thank you, Doctor. Thank you, Aditya. Thank you for taking us to your journey. I think it recalled me during my PhD days how we used to travel through the tribals, and I even learned walking with Gedi. Gedi, like the stick is there, and then you walk on that thing. So I agree with you. I think that you mentioned a very important point that the most people focus on the above ground diversity, that is plants and those things, and people are not understanding the kind of below ground diversity also plays an important role in the kind of sustainable thing. And it was nice to see the correlation between the trading within the mushroom. When they require something, they have to produce something. So definitely the bio of a material is definitely stay. I think it will stay for long and replace the thermocone and styrofoams. And not to forget the very nice creative arts and gallery you showed us. And hope this natural Fevicol, as you mentioned, expands fast in the market. Thank you so much, Aditya. Thank you for taking us through your journey. Yeah.
Thank you, Aditya. Stay with us, please.
Moving ahead with our next talk, Dr. Yashaswini Balaraju, co-founder and chief product officer in